So if you take a look at the problems that we have, this is actually our second day of working on factoring completely. But these examples, some of them will have a common factor. So let's take a look at the first example. And this one has a common factor of 3x. So we need to factor out a 3x. So 3x times x squared minus 1. And now we should recognize this second piece as a difference of squares. So just because you've done one factoring bit, as we said on the ones we just finished explaining, don't stop. This is now a difference of squares, so you hopefully remember that that's x minus 1 and x plus 1 when you factor it. Okay? So difference of squares, sum of cubes, difference of cubes for the binomials are always something that you're going to want to check out. Let's take a look at the second one. In the second one, you'll see that we have a common factor of 4. So 4 times x squared minus x minus 6. And now we can really guess and check this last part. Factors of 6 that add or subtract to give me 1 are going to be x minus 3 and x plus 2. And I know that it's minus 3 because the larger number is going to take on the sign of that middle term there. And don't forget to bring down your 4. So factoring completely is going to be on your quiz next time. And here are 2 more examples. Again, we're going to factor completely, and the first step is always, is there a common factor? And the common factor for this one is 2. So 2 times x to the 4th minus 81. Now, hopefully you recognize this as a difference of squares. Remember, when we have something to the 4th power, it can be a difference of squares. Any even exponent there can be a difference of squares if you want to examine it more closely. So the square root of x to the 4th is x squared. So it's going to be x squared and x squared. Bring down that 2. And the square root of 81 is 9. So one of them needs to be plus 9 and one of them needs to be minus 9. And so this one's not finished even yet because here we have a difference of squares again. So bring down the pieces that are prime. And I want to take this time to point out that this is the sum of squares. And you can never factor the sum of squares. They're going to put that one on there, and you're going to need to say that one is finished. So now the square root of this is x, and the square root of 9 is 3, so it's x plus 3. And so now we're finally finished with that one, factoring completely. But again, this piece, they're going to try and trick you into factoring this again, but that is the sum of squares, and the sum of squares is prime. Okay. In the next one, we have 4 terms, and you always want to factor 4 terms by grouping. So factoring by grouping, of course, we're going to ask ourselves, is there a common factor for all 4 terms? And the answer is no, there's not. So I'm going to look at the first 2 terms, and the common factor is x squared. And so this was going to be x plus 2. And I'm going to look at the second 2 terms, these 2, and the common factor is negative 9. So negative 9 times x is negative 9x, and negative 9 times 2 is 18. So now you're going to see that we have a common factor here and here. So when I factor by grouping, I'm looking for that common factor so I can write it once and then write the other pieces, x squared minus 9. But hopefully you recognize this now as a difference of squares, so you know that you need to keep factoring that. So x plus 2, and then x minus 3, x plus 3. And so the message for the ones that we're practicing today is going to keep factoring until everything is prime, until every term is prime. Okay, so finally, again, we're going to look at this, and as I stated before, they're going to try and trick you into factoring that. This is two terms, but it's not a difference of squares. This is a sum of squares. So you can't factor a sum of squares. This one is prime. So look for the ones where they try to trick you into saying that it's x plus 8 and x minus 8. So let's just kind of do a test. If this was the case, would I multiply them back to get that? This would be x squared. This would be minus 8x. This would be plus 8x. And this is going to be minus 64. So while these two middle ones do cancel, I get minus 64, not plus. So this will not factor as 8, as x plus 8 and x minus 8. So it's kind of similar to the sum of cubes problem that we did earlier. Those middle terms need to cancel, and that's why this one's prime, because the sum of cubes won't cancel that way. All right, and the last example I have for you today is kind of interesting. First, because we have x squared y, but also I'm going to show you a tip, and that is factoring out a negative 1. So let's see when that's necessary. So this is no common factors for all 4 terms. So this is 4 terms. So one of the tips that we have is factoring by grouping. So in the first 2 terms, y is my common factor. So this would be x squared minus 16. Now in the last 2 terms, my common factor would be 2. So remember, I told you kind of that goes with the next step. So what happens is I get 16 minus x squared. So what I'm going to notice is that this is not quite the same thing as this, but they look a lot alike, don't they? And you need to know that subtraction is not commutative. So I can't just change their order. But what I can do to make them look a little more alike is instead of factoring out a 2, I can factor out a negative 2. Now let's see how that helps. Negative 2 times 32 is going to be negative 16, because negative times negative makes a positive. And then this one will need to be plus, right? And this one's going to be x squared. So this helped me because this now matches this, because addition is commutative, isn't it? So what we're saying is that this is the same thing as this, isn't it? So that negative 2 trick was handy because now they match, and I can use that factor by grouping rule to finish that up. Remember, they have to match, or you can't use that. And now this is a difference in squares, so it's x minus 4, x plus 4, and bring down that y minus 2. So those problems, we have to factor a couple of times on some of them. All right? So I have some practice problems for you now.